Hi everyone, in this video we're going to look at a few examples where we need to find radian measure of an angle if we know its function value. For our first example, we need to find value of angle theta if we know that this angle is in the given interval, so from pi over 2 to pi, and that cosine value of that angle equals -1/2. Generally, when we give a sine or cosine value of an angle, finding the answer will be easy, since both sine and cosine values are shown on the unit circle as the coordinates of the points that are labeled. So the only thing that we need to consider here is that interval. There are a few things that I want to remind you. So first of all, when we look at the interval, the first number always represents the beginning of the interval, so from this value. And the second number tells us where that interval ends, so from 2. So from pi over 2 to pi. And the second important note that I'd like to make is that when we're trying to find an interval on the unit circle, we always have to move in the counterclockwise direction. Okay, so let's try to put this together. From pi over 2 to pi, moving clockwise, well, that covers quadrant 2, right? So for which angle in quadrant 2, cosine value is -1/2. Remember, cosine corresponds to the x-coordinate of a point, so it must be this one, -1/2. And therefore, angle that we're looking for is angle 2 pi over 3. Angle theta is 2 pi over 3. Let's try another example. This time we need to find angle theta if it's located between pi and 2 pi, and its tangent value is -radical 3. So let's start by locating the quadrant or quadrants that are covered by this interval. So from pi to 2 pi, moving counterclockwise. That interval covers quadrant 3 and quadrant 4. But are we going to look at both of them or not? So for that we need to notice that the tangent value that's given is negative. And that will actually narrow down our search, because out of those two quadrants, tangent is negative is only in quadrant 4. Okay, so now we know where to look at, quadrant 4, but what is the angle itself? Remember, tangent is not labeled anywhere on the unit circle. So to find our angle theta, we're going to use the reference angle. Since reference angle is going to have exactly the same numerical part for tangent as our angle, we're going to look it up in the table of values. Here's tangent, and I'm going to find radical 3. Here it is. And I can see how it corresponds to pi over 3. Therefore, theta prime, the reference angle, is pi over 3. And that's going to be the key to finding our angle, because we know when we work with radian measures, angle and its corresponding reference angle are going to have exactly the same number in the denominator. So in quadrant 4, I have to find angle with the denominator 3, and I can easily locate it. It's right here, 5 pi over 3. So angle theta that we're looking for is 5 pi over 3. So if I recap all the steps, then I'm going to say that in step 1, we had to identify quadrant or quadrants based on the given interval and the sign of the function. In step 2, we determined the reference angle because we knew that it had same numerical part of the function value, which was tangent, as the angle that we're looking for. And in step 3, once we knew what the reference angle was, we were able to find our angle based on the quadrant determined in step 1 and based on the denominator of the reference angle. They have to be the same. So these are the steps for finding the unknown angle if we know its function value and interval in which that angle terminates.